Okay, boss. Yeah. Now we're going to focus on database view. See, there's a lot of difference when you're dealing with HANA modeling. You deal with attribute view, analytical view, calculate. That is different. And what we are referring now is normal database view. Yeah. Okay. So when do you go for a database view, boss? Let's say you have data in multiple tables. You would like to join them and then access it in the reporting. But your database view is virtual. See, ultimately you can store data physically only in tables. That's it. Rest all objects are not hold any data physically in them. Okay. And now, yeah. Is it better now?
Yes, sir, it is better now.
Hello.
Yeah, yes, sir, it is a little bit better now.
Okay. Yeah. So when you want to join multiple tables and formulate a projected set of fields, and we go with database view. And this view is different from the HANA modeling views. Okay. So I have a requirement. There's one of real-time requirements. Now look at this. I have this table and look at my requirement. Okay, boss. I have this data here. Okay. This is my data here. See, look at this. This is the details of some company, and this company has got some subsidiary companies. See what there could be a group of company which has got subsidiary companies within that. Like this is the information. This is the every company would have something called SIN, corporate company identification number. Yeah. So this is the list of subsidiary companies I've got. Say this is one subsidiary company SIN number and the company name and under which section that was been assigned as the subsidiary company. Again, subsidiary company 2, subsidiary company 3, subsidiary company 4. I got it like this way. We call this as account based model. Like each value is stored as a separate row in my tables. Okay. When I create universe on this table and then create my report, I get that in this is my problem. Say when I'm doing reporting on this,
Sorry, why are we building up this database view?
That's what I'm just showing you the reason why I'm building the view. Okay. So I'm just have a cross tab here. Okay. And then I'll just create a simple query. I just want to see that SIN number name and the value. So this is serial number, right? And then the values. I'll say sort as per this. It's all 67. Eh? Fine, okay. Look at this. It is basically aggregating these values and showing me downwards like this. For example, say okay. And I assign this out. I connect this and I fire this query. I'm waiting to see like SIN, subsidiary SINs, and these are the ones, and company names are this. But this does not have any relations. I cannot find out this SIN number is for this company, and this for this company, this was the section. I cannot really get this like if my table is stored in that way, I can only get a query like this. Suppose if I drill this in the columns, I'm going to get this way. Look at this, I get it this way. Means what? You get to see all the SINs across, and you get to see the section and the names across. But actually I'm expecting to see a small kind of table which shows me SIN numbers and the company name side of it, and then I would like to see under which section this was being registered as subsidiary company. That is what I would like to see. But in the backend, my database table stores data in this format. That was the reason I could get data only in that view, in that format. Getting this? So now, two options you have. You either convert this in a required format and load into a different table and then use that table for reporting. Or at the runtime of the query, change this into different view, what you want, and then use it for reporting. If I store it another table, again the data becomes duplicate. Unnecessarily I'm storing the same data again and again, right? So I would like to create a virtual object which can just project me in the required way what I want. Clear on this? So I'll try to build a view. We can build your database view either using SQL or even with UI also. But with SQL you have much more flexibilities. With UI it's only very limited options here. Okay. So first I'm showing with SQL and then we'll get. Say create view. You want this in which schema? 9 cubex SQL dot subsidiary companies. This is my name of the view as, and then start formulating a select statement. See, we're going to write some very big select statement. We might be confusing, but we'll learn the select statement later already. Okay. So we're going to formulate a select statement which will actually give the result of the select statement will be projected as a view bus. So I'll write a select so that the account based model which is stored in the table will be converted to a row based model what I want. Okay. So we'll just have to write all the select within this. That is about creating a view. Yeah. So slowly I'll start formulating. What is my logic? What I'll do is first I'll try to say select. I just want only these, right? I'll just say select. So what I'll do? Actual value, right? Actual value. From which table? This is a table. So I'll say select actual value from this table. And I just wanted to be reading data only for which section was. I have this. What is this? Subsection has this value, right? So where subsection. Since this has got some special characters, I'm putting in double quotes. Subsection S capital S. So what will this give me? This will just give me all these values, actual values, right? So I think select actual value, the column actual value from this table, where the section is I9B_1. So it just gives me all this list here. Okay. Further, I just want to read only the SIN numbers first. Okay. So just to read only SIN numbers, what is again selection I'll do? I'll say within this section, just read only where my extra field label is what? SIN_CBus. Can I say and extra label? Correct spelling. Extra field label is equal to what? SIN_C. See, this is a value, string values I put in single quotes. If it is the identifier, whether it's a name of the table or a column name, I put that in double quotes. Let's fire this. Now this will just give me only subsidiary sins. Yes? Okay. Next one. I take the same query. Instead of saying sin name, what is this here? I'll take same section, but I'll say refer to what? Company name. This will give me company names. Okay. Okay, I'll format one more node. Okay. Set up my table, which is what? Section name. So this will give me these sections. So actually I've got three select statements which are like they just give me three sets of data. One is giving me subsidiary companies. I've just taken out names separately, sections separately. Now I need to group them to formulate my view bus. Or I need to join these. This is like one result set. This is one result set. This is one result set. I need to join these three result sets to formulate a view for me, what I want. But look at this. If I need to join this, but actually if you look at it's all sorted out. Means the first sin must be joined with the first section, must be joined with the first name. And there it goes. It's all sequential for me, right? The first sin must be joined with the first company name and must be joined with the first section name. If I just say without any ordering, if I just say join, if I do something like inner join, every sin will be joined with every name and every name will be joined with every section. It creates multiple combinations. That is not what I want. I want the first sin number must be joined with the first name and must be joined with the first section number. Means first row, all the first rows must be joined and all the second rows must be joined and all the third rows must be joined and all the fourth rows must be joined. Right? So if I just go with just joining this, I can't achieve that because every record will be joined with every record. That's my problem. So what I'll do, apart from this, in each result set, apart from the actual value, I'll try to generate some row number for each of this. Say in result set 1, you'll have 1, 2, 3, 4. In result set 2 also you'll have 1, 2, 3, 4. In result set 3 also you'll have 1, 2, 3, 4. Then I'll say join this result set based on that row number. So 1 will be joined with 1 and 2 will be joined with 2 and 3 will be joined with 3 and 4 will be joined with 4. Then you don't have this combinations created. Right? So to get the row number, we can use a function. One second. You have a function for generating a row number. So you got to say this way. see this is the function row underscore number. But actually there is something called Windows functions which we'll see later. But whenever I use Windows functions, I must always specify sorting or order by. Nothing but order by is actually sorting. Yeah. We'll see the syntax later. I'll say I want some column, right? I'll say use this. Say I want row number over and order by this value. Over means like over this actual value, generate me a row number. Now let me just select this and see the results. And whatever I'm getting it, I'll just set that as row number, I'll say, as a column, alias. Okay. The row number, so you're going to get a row number and what? Actual values. So to generate some sequential row number, I use this Windows function called what? Row number. Okay, was? But whenever I use this is actually Windows function and simple. Say for example, you have certain result set. It divides that result set and performs that function. That is called Windows function. For example, you have been given with list of students and list of their marks, and you're supposed to announce who is the first rank, you're supposed to do the ranking within that students. So based on the highest marks, you start saying the one which highest marks is first rank, the next highest is second rank, third rank, you give it. But what has happened is they've given you some list of students with their marks, right? But those students belong to different sections. They've given you 10 students marks, but actually student number 1 to 5, they belong to section 1. You know, we have sections in the classes, right? Section A, and 6 to 10, they belong to section B. So now I would like to do ranking by dividing that data by sections. So I need to divide that result set by section A, section B, then do ranking. That is Windows function. When you partition the result set and then do execute that function, those are called as Windows functions. Say use rank function over section number. Section means split by section, then order by marks. So when I do order by marks, then what happens? The student with highest marks will be coming at the top. We will say descending order by so and so, descending order. So what happens? So when I say over section, then what happens? The result set is divided by what? Sections. Then I'll say order by marks. Here the entire result set, I'm not splitting anything, so I'm just using over. That's what I'm not using saying over this field or over. I'm not splitting anything. I'm just using what? Only order, and I get the row number. Same way I get the row number for other 3 result sets. If I take this again, you get serial number for each of the company name. 1, 2, 3, 4. You'll get serial number for each of the sections. 1, 2, 3, 4. So I need to take these. Assume this result set 1 is like table 1. This result set is like table 2. This result set is table 3. And I'm trying to join these 3 and formulate one single view for it. Getting this? Okay. So I'll say. So ultimately, what is it you want to select? Let's say select. Okay. Assume this as a table 1. Okay. I'll come to that. So I just want, let's say just select actual value from what? From which table? This is a table, right? This is sub select completely. Can I say this is table 1? I'll say I give it alias as T1. So select actual value from, instead of giving a table name, I'm giving a sub select there, which is actually representing my table. That is just giving me actual values from the sub result set. Okay. It's actually subquery. This itself I'm referring it as one table. From that I'm reading what? Actual value. I'll say what? Can I say explicitly I want, since this table has been referred as what? T1, I'll say T1 dot actual values. Okay, good. Now once I have this table 1, I need to join this table to another table. So I'll say what? inner join or left outer join, whatever the type of join you want. Inner join, which table was? So is this another table now? This is table 1, right? And inner join, yeah. For you to understand, okay, this is for table 1. Inner join, which is named as, I'll name this as table 2. So this result set is considered as table 2 and this result set is considered as table 1. I'm joining this table 1 inner join with table 2 and you need to have some join condition on what? On T1 dot which field was? Or join with the row number. Yeah. T1 dot row number is equal to row number. So now here I need T1 dot actual value will give me SIN number, subsidiary company name, and then what? I'll also read T2 dot actual value also. Yes, because T2 dot actual value will give me what? Name of the company. Then again, this result must be again joined with what? Another table again. I'll say inner join. Okay. Inner join. I'll name this as what? T3 on T2, T1, anything is fine. T1 dot okay. And that's specified join condition. Now I need to read even the actual value from T3 also. T3 dot so this select will start giving me the result of the join completely. I got all this set sitting in one place. Okay, boss. I'll take this select and I'll put inside what? Create view so and so as అంతే. ఇక్కడ అన్నిటికి ఇప్పుడు ఈ క్వెరీ కొట్టింటే ఏమొచ్చింది అన్నిటికీ చూడు యాక్చువల్ వాల్యూ మంచిది కాదు కదా, నాట్ గుడ్. సో ఐ కెన్ యూజ్ alias name. I'll say T1 dot actual value as what? Subsidiary SIN, yeah. T2 dot actual value name as what? I can give alias name as subsidiary company name as subsidiary section. Just executing only the select part. Now they start giving me the respected headings whatever, and then based on this output of this select statement, I want the view to be different. I'll say create view so and so as this. That's it. Select the complete set, and you should have a parenthesis close at the bottom. That's it. This will create a view for. That's it. Now, so you remember in which view did I create that? I said in 9QX SQL. You see a folder. What is folder here? Views. You should start seeing this. Subsidiary companies view. Right click and open data preview. This is virtual. When I try to see the data, of this view, at the runtime will read data from those query and then project me as the result. Okay. And even after creating the view, I can still see the definition. As you can say open definition, I can see the SQL schedule what was being used in the backend. Okay, was fine. See, actually, why I was just touching this. This was very, very important for in our project. Actually, the data what I was showing you here. The data what I was showing you is about some company. For one company, I get around 700 rows. Means each row is one kind of information about the company, saying for this company the filing was done on this day, for this company this was the director one, this was the subsidiary company. I get around 600 rows like that. And then I have asked the BODS person, to get the output this way. He was asking me lot of questions. ఇవన్నీ ఉంటాయి, 4 ఉంటాయా, 5 ఉంటాయా, 10 ఉంటాయా అంటే I can't say, because there could be company with 50 subsidiary companies, there could be a company with 100 subsidiary companies, ఎన్నో వస్తే రావాలని అంటే I wanted to he has to do lot of looping and he has to do lot of logic to convert those data into this format. Okay, and performance was really bad. Then I said, okay, say, let me write a view in database language. And same kind of logic you can achieve with HANA modeling also, like with attribute or with analytical view or calculation, we can achieve that. So దీనివల్ల నాకు చాలా బెనిఫిట్ అయిందన్నమాట. అంటే యాక్చువల్లీ దిస్ వన్ టేబుల్ యూఆర్ సీయింగ్ లైక్ దిస్, రైట్? There are around 9 to 12 tables which what BODS person does is he extracts data from the source as one table with 600 records. I tell him what all to be formatted as a table, converted as a table like this. For each table formulation, he builds one separate data flow with lot of looping. Say fetch record 1, make it reverse pivot, fetch record 2, make it. He's doing lot of stuff where the processing of the record was very slow. Then I said, leave it, just dump into the table. Let me play it into the query like this. So if someone asks you when any scenario for database view, you can use the same scenario for HANA modeling also, calculation view, analytical view also can. Okay. Our topic లేదు కాబట్టి ఇక్కడ అదే లాజిక్ ఇక్కడ పెడుతున్నాను. So on top of this database view, I can create universe and then project that universe and then do reporting. అట్లా నాకు అలా చేసినాక వచ్చిండేది ఇది. I created a view like that. I create a view like that and I create universe also. This is that universe. See, I got subscriptions. I getting this? And the same thing, I'm just projecting this thing. You would right? So then can I say your question real time scenario in the data might be different, the content might be different, but this was one of the requirements where we used view. The data what we had in the table was not ready for consumption in the reporting directly, so we had to change the view of it. Then we created a database. So we use virtual again. Okay, this is one way of doing it with writing SQL. Okay, and we can also create view with UI also. Well, ఆయన అట్లా చేయలేదమ్మా. He was using some reverse pivot function and then he was doing some looping. Yeah. ఎందుకంటే in BODS it process record by row. It cannot process result set by. What I did do? I've just taken result set to 1 with multiple rows. BODS can't fetch like that. It only process row by row. Okay. So we can also create database view with drag UI also. Yeah. So for that, I have a table. I just take simple record. I have a table called customer. This is my customer table, and I have a table called fact sales. This is straightforward, simple one. So in the fact sales table, I see the details of the sales. Each row is one order ID, and for each order, it could deal with. See, if the order ID is same, obviously the product would be different, because when the customer places an order, does he place for one order or multiple orders? One item or multiple items? See, if you look at this order 775, it's got it deals with lots of products. This product is rendu same unda. This might be something which I added. Okay, boss. Yeah. You see product being different, and then you have something customer ID. And I'm not worried about this. I've got a column like net sales, which I'm interested in, and then I'm interested in this column. What is quantities? So this table tells me for a given customer what is my net sales and quantities. And this table tells me for a given customer ID. What was the customer ID there? 17, right? Rendu సార్లు వస్తుంది ఈ డేటా 2 సార్లు సర్లేదు రాని I have this 17 for customer ID 17. I know to which country or to which region or to which city does it belong. So I just want to have a view which gives me for customer wise net sales and so where I've got supposed to join this fact table. What is this here? Customer ID with what? Customer table, customer ID. For joining, the column need not be same. Here the column name could be customer. Here the column name could be customer ID. I can still join them. As long as the data element, the data within that column is same, I can go about joining them. It's not necessary that the column names must be same, right? Yeah. అవును ఏది మనకు అంత అవసరం లేదు రెండు టేబుల్ తగిలి అంతే అది మన కాన్సెప్ట్ యా when required we can write any logic. Okay. So I just want to create a view in this schema 9 cubic SQL, but I'm referring to tables of different schema possible, no issues here. So I'll right click on this views folder and say what new view. I want to go with UI, say something like say customer sales something, and which schema I'm creating a 9 cubic SQL. It's like more like a canvas, okay, where I basically insert the tables what I would like to have. Insert table. I would like to go with the table from schema cubex SQL. One is customer table. Control button రెండు ఒకటేసారి చేసేయలేదు ఒక్కోసారి ఒకటే. Okay, yeah. Here cubex SQL. Next is your fact sales. Okay, now I would like to perform a join between these two tables. Yeah. So I have this table, customer ID, and I would like to join this column to this table to get the details of customer. So from here, you try to do a drag and drop. As soon as you drag and drop, it asks me what type of join are we using. So none is like inner join, left is left outer join, right is right outer join, full is full outer join. So we understand what is inner join. Inner join is what? Only the common values. Left outer join is what? Inner join plus the left operands, okay. And right outer join is what? Inner join plus the right operands. Full is like inner join, left and right operands completely. I'm okay with inner join now. Yeah. If you're okay with drag and drop, you can do this way. Or you can right click and say insert join. Or even here you can say insert join anyway. So choose what I want my fact sales to be the left table, and I want this customer table to be right table, and you want join on the customer ID. So select customer ID, make sure you select customer. So here it forms fact sales dot customer ID is equal to customer dot customer ID. And if I set this, what happens? A out, left out, left table then outer bit left outer. Then you put then it becomes right outer. Rendu pedithe full out. Ante endu మనకి ఇప్పుడు inner join right. So it's none indicates inner join. Then I can start selecting what columns do you want. From this I want to see company name, region, and then I want net sales, and you can just select columns from there. That's it. You can, if you want, you can use Synonymn and change the name of the column. So instead of projecting as company name, I want to project as customer name. I can do that. And you want that to be visible or sorted or what? Or you want to have some conditions kind of stuff. We can do sorting, or predicate means like operator. You want to use some where class selections, you can use. I'm okay. I'm just saying what? Activate. So what it say? Create view, so and so it is execute some SQL statement and the view is created. This is bug, no one anga. Okay, this is my view. So if we just try to see the content of this view, I get to see customer name, region name, net sales and quantity, which has been projected. I can also see the SQL definition of it after creating. If I go to open definition, I can see the SQL sheet what is found. Says, look at this, inner join. After the view has been created either with UI or something, I can also see in the definition, I can see the SQL statement what is found in the backend. But if you're going with UI, you're limited with these options. If you go with writing SQL, there's no limit. You can go with anything you want. As you were saying, I want to use distinct all this. You don't have those options. It's better we go with SQL and then yeah, what is your
Very similar to IDT.
వాళ్ళది అది కూడా మాదే కదప్ప సేఫ్ అలాగే ఉంటాను సేమ్ అంటే నువ్వు వాట్ ఎవర్ యూ బీన్ డూయింగ్ ఇన్ ఐడిటి దే ట్రై టు పుష్ డౌన్ ఇన్ టు అన్న అంతే pretty much కొద్దిగా ఆప్షన్స్ మారుతాయి ఇంతేనా దిస్ అబౌట్ డేటాబేస్ వ్యూ బస్ ఓకే the next is synonyms. So if you want to really be strong in creating view, it's like we have to be strong in select statement. We'll come later on that. We'll come in detail about DML statements, data manipulation statements, where we deal completely more focusedly on select statement completely. Next is synonyms. Next database object type synonym. But the view what we have seen is a database view that is completely different from the HANA modeling view. Those are different. This is different. Okay. Okay. Synonym. Synonym is like you can understand like a shortcut name. You can understand that as a shortcut name for any database object. Say for example, for a table or for procedure or whatever it is. Simple. Say. So I have this table. I don't know whether data is there or not. So I have a table with some data in it. Okay. But what is this table name here? EMP with the data bus. Okay. But what I want is I would like to provide some alias name for this table as EMP. So whenever I write my query, if I just refer as EMP, it should refer to the table, like a shortcut. Windows lo shortcut unnattu. Alias name. Yeah, that is nothing but synonym bus. Okay. I can also create synonym majorly. See, I'll say like this. Create, very simple. Create SYNON. Create synonym, okay. And you would like to create this synonym in which schema? 9QX SQL. What is the name of the synonym you want? You want it as what? I want the synonym name to be EMP. For what? This shortcut name EMP should be referring what? For so as soon as I create, select this and say create. Okay, boss. Now once I have this, now look at this. Now when I go to, you see another folder here. What is this? Synonyms. When I get in this, you see a synonym called EMP, and you see a small icon here. Shortcut lag. When I try to see the data of this synonym, it actually shows the data of the table which is represented by that. Okay. So I can also run this, even if I run my select statement, say select star from 9QX SQL EMP, it is actually referring to what? Indirectly it is referring to EMP with the data. That is synonym. Okay. Not only to table, I can create a synonym for a procedure also. Let's say there is a procedure which is a really big name. I can just provide some alias name or synonym for that procedure and call that procedure with that name also. This is synonym. Okay. There's one more. Is it like reference object?
But it will be confusing, right? Using both the names for configure name different yes name.
నేను బలత్వం పెట్టలేదన్న వాడమన్నా అవసరం ఉంటే వాడు. Okay. Next one. There's one more concept. See this synonym was, I'll come to that. This synonym is created in which schema was? 9 cubic SQL. If that is done, if that is the case, this synonym can only be accessed by user who has got access to the schema of what? 9 cubic SQL. This schema can be, this synonym can only be accessed by a person who has got access to the schema code, what? 9 cubic SQL. But let's say there is some kind of table which is giving me list of holiday calendar or something. There is a table which is giving me holiday calendars or factory calendar or something, which I want everyone to be seeing those tables. I want to make those tables global and everyone should be able to see those tables first. Then what we can do is we can create something called public synonym first. We can create something called public synonym. To create public synonym, it will create the synonym. Use a keyword what? Public. Create public. So when you're creating a public synonym, are we creating inside a schema or outside? Outside. In a schema, you don't have to specify schema where it has to get created. You just give a different name. So you just use a keyword public to make the synonym as a public. And when the synonym is public, it is not specific to any particular schema at all. Okay, boss? So I've just removed, there's no qualification of the schema name for this table. Let's select this and say create. So what is my public EMP, right? Now look at this. All your public synonyms will be in this folder. This folder called public synonyms and try to filter for even though the user does not have access to the schema 9 cubic SQL, he can still be able to see this synonym. This is called what? Public synonyms. Question is here. Above, it's not in any of the schemas. It is all as public, global. Yeah. Indirectly global public schema system global pettukundu, but you treat that as only folder. That's global folder, which is not specific to any of the schemas. That's the public synonym. Okay. Now the question is, why should I use synonym? What is synonym? Synonym is like an alias name or a shortcut to a database object. It could be table or a procedure. It's a shortcut or alias name for a database object, which could be table or a procedure. Now we could create normal synonym, which is specific to schema, or we could create a public synonym, which is global. Anyone who is able to log into HANA will be able to access the public synonym, whether he has got access to the schema or not. But why should I create synonym? The question is, why should I create synonym is what the point was. Okay, good. Now look at this. There will be some specific cases where the synonym could be really important. First point with the important normal. Suppose say you're developing some applications. Yeah. So database will be developed. Database development will be going on simultaneously. Let's say the front end designing is also going on. Architect. So front end had a vision that they're expecting a table with the naming as EMP. Okay. But in the backend database, the table was created as employee. But instead of dropping and recreating with EMP, can I solve that problem with synonyms? So I'll create a synonym as EMP as employee. So front end people still, even when they query saying EMP, they're still able to get their database. Alert case, general normal, we can solve those kind of, that is okay, generally. Yeah. Next major the real time question is currency conversions is very important. See, people from SAP background would understand, say, when you, in SAP systems, when you do currency conversion, it actually does leverage some currency conversion relevant table, standard table, T-cur X, T-cur F, T-cur C, all this, right? there will be some standard tables in the backend which will be leveraged for currency conversions. So in all your SAP applications, the programming, the above program for converting currencies is written or developed in such a way that it refers to the content of a table with the naming as Tker C, Tker, Tker F, Tker X, or whatever it is. Then perform the currency conversion for it. It's all default maintained like that. Okay. Even in SAP HANA, when you got to do currency conversion, it would still the scripting or procedure for currency conversion in HANA is written such a way that it expects to see the currency conversions or currency codes or factors or exchange rates, everything from the table maintained with the naming as Tker C, Tker X, Tker F, Tker V, all those stuff. అంటే HANAలో కూడా SAP applications లాగానే ప్రోగ్రామ్ రాసి ఎట్లా పెట్టినాడు, whenever I do currency conversion in SAP HANA, it tries to refer to the table with the naming as Tker, Tker C, Tker F, Tker X అని కొన్ని ఉంటాయి. అంటే Tker C is for holding all list of currency codes. Tker X is to hold all the currency exchange rates. Tker F is to hold the factors of all అట్లా టేబుల్స్ ఉంటాయి. ఆ టేబుల్స్నే వాడుకుంటుంది అన్నట్టు HANAలో కూడా అంతే. Okay. So in the interview also they ask you this question. They say, okay, this is what happens. So if you have, if the product is say you're extracting data from ECC and putting into HANA, then what happens? When you extract data from ECC has got the tables like Tker, Tker C, Tker F, because that is SAP application, right? So those tables are brought in, and then by leveraging these tables, you can do currency conversion straight away. No issues here, right? But imagine you're extracting data from a non-SAP source, let's say from Oracle or SQL Server database. In those databases, the table names are maintained as exchange rates, currency codes, or currency factors, or what own naming lo pettukunnadu. Let's say I replicate those tables into HANA. So what are the tables I get? Exchange rates, currency codes, factors, and wherever table pair those. And when I say do currency conversion in HANA, HANA is trying to refer to a table. The standard program or standard procedure or standard scripting of currency conversion in HANA is already implemented to refer to a table with the naming as what? Tker C, Tker X, Tker F, all this. So in that case, how do you solve this? So can I go with synonyms then? In the same scheme, I'll say create synonym Tker for exchange rates table. Create synonym as Tker C for a currency codes table. Create synonym Tker F for factors table. Can that be a scenario? Real time did you work with currency conversions with non-SAP source? Yes. We have replicated data from non-SAP sources, but the table names are completely different. We have to go over creating synonyms for it with Tker, Tker C, Tker F. Then the HANA application was able to, in HANA application, we were able to perform currency conversion. That is important. See, it's something like this. I'll show you. See, in this, I've got some set of tables. I've got some set of tables. This table, sap.hana.demo.content.epm.data : this is giving me currency codes. It is giving me list of all the currency codes in it. But my engine or the standard programming for currency conversion would need a table with what name? Tker C's. But what is the table name? In the table. ఇలా ఉంటుంది non-SAP scenario, right? So అప్పుడు మనం ఏం చేస్తాము, ఇక్కడ సినోనిమ్ చేసి పెట్టినా ఏమని ఓపెన్ డెఫినేషన్ అంటే చూడొచ్చు. Tker C is a synonym in the schema for referring to what? SAP.HANA ఈ టేబుల్ కి ఇది synonym. Okay, boss? Okay. Means like reading, yeah. లేదు అంతే అంటావా? చూస్తాం. పోతుందమ్మా ఇన్సర్ట్ కూడా అవుతుంది. ఇన్సర్ట్ డిజేబుల్ ఇన్సర్ట్ ఇన్సర్ట్ ఏంటంటే ఇంకా అప్సర్ట్ అప్డేట్ అన్నీ ఉండాలి. And same way you will have it for unit conversion also. So for currency conversion, it does leverage standard tables, T-cur, C, T-cur F, T-cur X అని ఇది కొన్ని వాడుతుంది. సేమ్ అట్లా యూనిట్ కన్వర్షన్కి T006 అని వాడుతుంది. సేమ్ అదే కాన్సెప్ట్ యూనిట్ కన్వర్షన్ కూడా. Suppose let's say the unit conversions are maintained with a different table with non-SAP source. When you replicate it, you must create alias name for it with what? T006, so that your standard program in HANA can refer to the T006, which indirectly refers to the unit of measures. Okay? Yeah.
Can we use these synonyms for views as well?
In which view?
Any views we created on the standard table.
Database view you can use. Is asking, can I have a select on this alias name or synonym be used in creating my view? Yes. Database view, yes. But I cannot use this synonym in HANA modeling. No. HANA modeling only column store tables. But no synonym, nothing is allowed in HANA modeling. Straight away you have to use table. Okay, Nanda?
Okay, thank you.
Okay. Yeah, what is it? ఇదమ్మా ఇంతేమో తీసేసి అట్లా ఇది మన కమాండ్ ప్రాంప్ట్ కాదు కదమ్మా. అది నువ్వు సీక్వెల్ అది వేరే, ఇది అట్లుంది ఎడిటర్ అని.
మనం ఒక టేబుల్ క్రియేట్ చేసి రైట్ క్లిక్ చేసి రిమూవ్ అంటే రిమూవ్ అయిపోతుంది. అలా కాకుండా అథెంటికేషన్ ప్రొవైడ్
చేయొచ్చు. Is asking me a question saying, when I right click on the table and say delete, the table gets deleted. Can I control that user not to have the delete authorization? Yes. That's simple and you save them.
Hello.
Yeah, 1 second. We go to this user, object schema ఉంటుంది కదా, ఈ స్కీమాలో వాడు ఏం చేయొచ్చు అని ఇవ్వచ్చు అన్నట్టు. క్రియేట్ ఎనీ, కెన్ ఈ ఆల్టర్ ది స్కీమా, ఎగ్జిక్యూట్ ఇక్కడ చూడండి, ఈ డిలీట్ ఈయన అనుకో, సో యూ కాంట్ డిలీట్. You can control what kind of privileges do we have on that schema. So if you just give only select, you can only read. You will not be able to do delete. Yeah, what is the question?
Sir, is there any table store table and synonyms, so we can refer the table and see that term?
Can you ask me again? What is it?
No, is there any table to store all tables and synonyms if you are creating any synonyms like that?
He's asking me, is there any, like say yesterday we've seen a standard table like tables or m_cs_ table which is showing me list of all the tables. Same way can I have some standard table to see అన్నిటికీ ఉంటుంది. గుడ్డిగా వెళ్ళిపోవాలి, అడగకూడదు క్వశ్చన్. Because whatever the data, what are the objects you're creating, for every object it has to store metadata into ఏ అప్లికేషన్ అంతే, అదే లాజిక్ అన్న. నేను గుడ్డిగా నో చెప్తాను, ఎస్ అంటే. వై? బికాస్ any application, whether it is HANA, you take Oracle, whatever it is, if you create some object, it has to store the metadata to some repository table, obviously. Yeah. Same ఇక్కడ కూడా ఉంటుంది. What is that అంటే ఎత్తుకాలంతే. ఏముంటుంది లాజికల్, ఎవడన్నా ఏదో సినోనిమ్ పేరుతో పెట్టాలి, ఎంవ్యూ సినోనిమ్ ఏదో పెడితే దొరుకుతుంది. LMNOPQRS. System overview, system statements ఉంటుందన్న డెఫినెట్గా.
Okay, sir, no problem. Thank you, sir.
And where to place that SQL file? We had some PDF on that SQL. Remember? if you go down, there is something of systems information. It will tell you lots of standard tables view. Desktop lo pettu na. Somewhere I downloaded.
That's 9 లో
దొరికింది. ఇక్కడ BA systems view, in this reference there is a menu called systems view అని ఉంటుంది. దాంట్లోకి వెళ్తే like there is something called systems view reference that tells you systems view are ready-made views in the system schema, which will give all the metadata information. If I just go down, definitely there should be something. A synonym one outundanna. There's something called synonyms. Yeah. So there's a table called synonyms, which will give you all information about synonyms. Tables at tables, synonyms undi. Tells you whether public or not. Synonym for what it has been declared, whether it is object. The synonym is referring to a table or whether it's a procedure. Because I can create a synonym for procedure also. So whether it is referring to table or what it is. Okay, boss. Only public. Public kakunte specific schema kuntuna. If you want to see in schema underscore name. See, you asked me whether public is actually a schema for you in the internally, but for you it shows as a folder. Okay. For you it is 9 cubics. So there is one schema, synonym we create EMP representing this object, and what type of object is this? It's a table. So this is what he was asking. Metadata. Okay. Reference, there is something called systems view reference, which will tell you the information about standard tables, which is stored in what. Okay. And next, that's about synonyms. Next, indexes. Okay. Next, indexes was. Why do we use indexes? Why do we build? See, there's already primary index on the table, which is a primary key. Apart from the primary index, why do you build the second index on the table? Why? To improve the read performance on the table, right? But if you remember, in the initial discussion of column store table, we said each column itself is stored as an index. Then you don't really need a second index. We had a discussion there. In a column store table, each column values itself with unique values it stores as a what? One distinct value stored as an index, and each column itself will act as an index in a column store table. Then you don't need any other additional indexes. But what SAP says is, even though each column acts as an index internally, if you're trying to write a select, where you're trying to be very selective, saying, say 100 fields in a table, you're trying to say where field 1 equal to this, field 2 equal to this, field 3, you're writing lots of very big where clause where you're trying to be very selective, then index makes sense. Otherwise, you don't really need indexes. But if you're trying to be very selectively writing lots of conditions in the where clause, then having indexes makes sense. Otherwise, you don't need. Okay. And now, when it comes to creating second indexes, there will be two types of indexes. One is called as B tree, and one is called a CPB tree bus. When you create a second indexes on a table, the second indexes could be two types. One is B tree and one is CPB tree. B tree is like binary tree, and CPB compressed prefix binary tree. When you say B tree, it is binary tree bus, and when you say CPB tree, it is compressed prefix binary tree bus. Okay. Now look at the difference between these two. What is the difference here? Look at this. If I say, let's say I've got values like say C100, say C200, C300, and C400, and C5. Let's say this is my value, and I would like to maintain that in form binary. Binary is what? Every parent will have two children, right child and left child, and right child is always greater than the parent, and left child is less than the parent. So what I'll do, I'll store something like this. C400 and something like C500 here. Parent with two children, again this has got two children again. Okay, something like this. So first we will do this comparison, and if you're trying to search which is greater than, then it will go to what? Right part of it. And for every comparison we are reducing half of the probability. We are nearing to the half of probabilities. That is binary tree. That compressed prefix binary tree ante edante same ilage untundi tree lagane, but I give strings like this to search for. I give a very big string like this, and I ask you to come search for RE. I'll ask you to search for REQU underscore 126B MN BB so on is sir. First R you try to compare only first 6 characters or the entire string. System one thing. So it takes to only the prefix of it and build indexes only on the prefix of it. That is called as compressed prefix index, B tree index. It will be a binary tree, but does not mean the binary tree with a complete value. It just takes only the prefix of that string and uses that for building the indexes. And whenever we have used kind of strings, it tries to hold that. Ante manamu search etutam kadanna. Pedda string iste first mundu match into next part chustunle, the next part kuda chudu atla adu kuda ante system kuda ante.
Sir, please speak in English. I'm able to follow.
So what I'm saying, if you're trying to search for some string in this way, you prefer to search the first part of the string instead of searching the entire string. If I just can match with the first 8 characters of this, then the entire string is same, right? So what it does, it tries to build index only the prefix part of only the first 8 characters of the string, not the remaining part. That is called as compressed prefix binary tree. Okay. So now look at this. The create, basically you'll have a statement called create index, where you can create two ways. You can either create with UI or you can create with SQL also. But if you want to create with SQL, you have to use a statement what? So it is a DDL, right? So it will be what? Create for table, you'll say create table. For view, you'll say create view. For index, you'll say what? Create index. That's it. Okay. And what type of index does it create? When the column data types are string or binary strings or decimal types, or when the constraint is a composite key or non-unique constraint, the index is what? See, if you don't mention what type of index, see, While creating index, you can explicitly specify whether you want B tree or CPB tree. If you don't specify anything, what index does it create? And look at this. If you're trying to build index on a column string data types, if it is binary string data types or decimal types or part of composite key, non-unique constraints, like for all this case, it by default it creates index. What type of index here? CBP trees. In other cases, binary tree will be used. Okay, was fine. If neither B tree nor CPB tree is specified, then HANA database will choose appropriate index type. If you, while creating index, you can specify whether it is to be B tree or CPB tree. If you don't specify, HANA will find which is suitable for it. Based on these data types, if these are the data types, then it goes with what? CPB tree. If not, it goes with what? B tree as the condition. Okay. So you can have unique. Let me just create first with. So what 9QX SQL? Let me show you with UI. Then you understand those options. So I've got this table and I would like to build some index on this. Right click and say what? Open definition. And then go to the tab what? First say you want to edit this table. Then get to the index tab. Then say what? Add. Just give some index. See, when you go with type, there's something full text index. Don't worry on that now. We use the full text index when you deal with processing of unstructured data. When you want to do some sentiment analysis, then we do it. No, don't worry now. It's index and indexed columns. Now you want unique index. Is SC11 or not? Do you see the screen something like SC11 in our SAP systems? Yeah. You want unique or non-unique? Then you want to build index on which column? Employee name. Not unique, non-unique with employee name and say active. So just click here and there, then it gets refreshed, then it's active. See, it is executing instead create index so and so on this table with this column. Instead of you doing with UI and then it executing SQL schedule, I can also directly say with SQL also. But in the UI, it doesn't give me an option of choosing what type of index I want, CVP or B tree. But in SQL, you'll have that options. So I'm just creating a table, so and so. Now let's create index on this table. Say create index so and so. Now this is the name of the index. On which column? On schema name, table name, column name. So even if we create this, I can see that in EMP simple IND. If I open the definition of this, I should be able to see that index is correct. You can either create index either way. Now I want, again, I'm create one more table. See, this is a normal index, non-unique, right? Next, I just want to explicitly create a unique index. So then in that case, I'll say what? Unique, I can say. If you explicitly, I want to specify the type of index. I want what? CPB tree index. I want unique CPB tree index. This is my index name on this column name. I can say this. If you don't specify anything, system will define what should be the appropriate, whether B tree or CP. Otherwise, you can explicitly specify also. So before the index keyword, you will specify what type of index do you want, whether unique B tree or CPB tree you want. EMPIND. You get to see this is unique here, but you don't see any index type B tree, CPB tree, but there will be another standard table as we've seen like tables or synonym. There will be a standard table called indexes, which will show you information about all the indices. There's a table called what? What is indexes, which will give you all currently indexes. And if you want to have the information about the columns on the index, then you have another table called index underscore columns standard table also. Okay. That's it. But if you don't specify anything, whether what type of index, then the system will define the suitable index. So I can just say only unique, or unique what type of index also you can. This is about creating a second index on a table. But generally you don't go with this because majority of the case column store is able to handle. Because in case of analytical applications, the where class would not be so very depth. Let's say you've got 1 million rows, your where class will not be such way that you're reading one row. Allow to do that. So only when you have that kind of requirements in OLTP, generally they would go with indexing, second indexing. Otherwise, if it is column store, we don't really worry about indexing at all. Seriously, I'm using another database which is supporting column store. I'm just dumping data. I'm not really caring about performance. I'm just dumping and I'm getting good performance. I'm not really caring about normalization, denormalization, indexing, nothing. Straight away I'm just dumping and I will get the column store range alone.
So what makes the difference between create index and create unique index?
Unique index is unique, and if you don't specify anything, it is non-unique. Unique is like it's going to hold the distinct values. If there's a column which holds distinct values, then you can build unique indexes. But if there's a column which does not hold distinct values, let's say it is going to hold duplicates, then you can't build unique index. Yeah.
So in this case, instead of employee name, we could have taken employee ID.
Yeah.
That's because that is going to be unique.
Yeah, but already employee is already a primary key, right? So primary key is already part of primary index. You don't have to create index again on ID. Yeah.
Okay. No, that is okay. I just, I mean, employee name is not going to be unique. The names can be repeated. That is why I asked.
Exactly. But for me, it was about syntax. So I was not worried about.
Okay. I mean, that's only led the confusion. It's okay.
Yeah. Okay, boss. Then there's something like alter index also. Alter index is like, alter index does not mean you are changing the definition of the index. You're rebuilding the indexes. When it's a rebuild, for example, let's say you have a table, you already build the index on the table, then you have changed this table definition, then you want to rebuild those indexes, you want to refresh the indexes in the database, then you can say what? Alter index, your index name and rebuild. That's it. When you want to refresh the indexes, what has been created on the table, then you'll create rebuild. But alter is not about changing the definition of the index. You want to refresh those indexes. You remember SC11 activate JSM to rebuild indexes. Then when you want to do that way, you will use this option alter index, index name, and say rebuild. It will rebuild the indexes on the table. So we'll stop it here, and tomorrow we have to get into triggers, where we'll start writing a little bit on scripting. We will writing normal. See, I'll come in detail about scripting later, in detail about selection later. First, to just make you familiar about what is table, what is view, what is synonym, what is index. I'm just touching each one by one. Say, for example, tomorrow we're going to touch something else. But to learn about trigger, we need to be strong in scripting. Trigger is something like call of action. I insert some record into a table. After every insert, I would like to perform a logic by default. I have a table. I do some operation on this table, and every time I do this operation, I want some logic to be triggered. That is what we achieve with triggers, database triggers. So the logic, what it has to perform is implement. How do you define the logic? We define the logic with SQL scripts. So if you've got really define complex triggers, you need to be really strong in scripting. Mark scripting rather got basic do some trigger in them. Once you learn about scripting, you can implement any complex logic in triggering. That's what. So tomorrow we'll focus on triggers, and then then we have something. Wait, 1 second. Sequences, then the drop. So pretty much we would have touched this, and then we'll touch on procedures, functions, and the columns. You get the idea about every database object. Then we can get into DML statement, data manipulation. Then we'll get into procedural statement, scripting, and that's how we get it. Yeah, tell me, boss. Yeah.
Sir, once created index on a particular table, so after executing, hello.
What was it? Yeah.
So once created an index on table, so after executing select statement, so how do you know whether that index is created or not? Is there any trace is there, sir, to check that one,
Yeah,
whether
yeah.
that
Yeah, yeah.
index is triggered off?
Yeah, yeah. If you get into administration, there's some trace configuration. You can say SQL trace. For a SQL, you can have the tracing. Yeah. And when you switch on the trace, it will be basically showing the trace as a file. In your diagnostic files, you will see a file like .trc, which is the trace file. Then when you open, you start seeing the trace, what has happened. Then you see whether the index has been used in the trace or not. Yeah.
Fine.
Okay, boss. Meet tomorrow on the other part. Okay.
Sir, one last note, sir. Sir, hello.
Yeah, tell me, boss.
Yeah. In my HANA server, in my office server, I'm not seeing the catalog and all the things are down the catalog. I'm not seeing anything. What what I need to do
You may
to
not.
see the column?
Are you seeing a schema?
No, I'm not seeing any schemas also there. If I expand that one, it's showing nothing. If I expand the catalog,
Might be. See,
it's
Vijay,
not showing anything.
that could be a problem of filter. You just remove this filter like this. That could be one problem.
Okay.
Or other problem could be that, but at least you should find a schema with your username. At least that should be visible. So make sure you remove this filter.
Okay.
At least you should see a schema with your username. Suppose let's say you're logged in with user 50. You should, when you expand
Okay.
the schema, you should see user schema at least user 50. But that you are the owner of that schema. Yeah.
Okay. When I expand it, when I expand that one, it's showing nothing. That means I need to clear the filter.
One is, that's what, one could be a filter option. If you already removed filter,
Okay.
at least you should have seen your schema with your username, because you are the owner of that schema. That is minimum assigned to you. And if you're not seeing others,
Okay.
that could be an authorization issue also. Because even though you have control authorization, at least your schema will be given to you. That's what I'm expecting. Yeah.
Okay.
Yeah.
I'll check on that one.
Okay.
Thank you, sir.
Okay.